Welcome, fellow anglers, to today's guide of optimizing your fly fishing cast. Whether you're a seasoned pro or haven't even ever seen a fly fishing cast, mastering your technique is a must-do if you want to improve. In this video, we'll explore the physics of fly casting, exploring the timing and movements needed to help you achieve the perfect fly fishing cast. From learning the angles of the rod to getting the perfect timing of your cast, we'll cover everything you need to know to take your casting skills to the next level. For this project, I looked at many fly casts performed by the pros, and I took careful measurements on their timing while taking the gear they're using into consideration. After many hours of doing complex math and making careful measurements, I came up with the perfect fly fishing cast. For our scientifically optimized cast, the following gear is being used. A 9-foot rod, which is slow action, meaning not very bendy. A 0.2 gram fly, a Prince nymph fly. And also 12.9 meters of line, which is all level and even thickness throughout. Just like all fly line, this line is extremely bendy and malleable, which will be very important later in the video. As well, the following conditions are being assumed. So, no wind and very hot day, which means minimal air resistance. As I mentioned, I looked at about 5 professional guides on how to fly fish where they use similar gear, and I took an average of their timing and their movements. Some of the YouTubers I looked at were Flyfish Dan, Rio Products, The Orvis Company, Hardman Fishing Adventures, and Angling Focus. The type of cast I was looking at is the most used, which is called the forward cast. Our fly cast is set up with the following timing. At first, the rod is at rest. The angler then twists the rod back, pulling the line behind it. This movement happens with a very quick acceleration at the start and then constant speed for the majority of the movement until the angler reaches the back of the cast and quickly slows down the rod to rest. Then, the angler keeps the rod at rest while the line strains out behind them. Then the angler repeats pretty much the exact same movement as the back cast until the rod reaches about 35 degrees in front of them. Then they slowly lower it down, finishing the cast. And this whole movement takes about 2.3 seconds. Here is an angular velocity time graph to help you deepen your understanding. So let's look into what makes a fly fishing cast work and what makes this the optimal cast. At rest, nothing moves due to Newton's first law. As you pull back, the cells in your body turn chemical energy into kinetic energy, twisting your wrist back. Although the wrist does not move too much, the slight movement profoundly impacts your rod due to the physics of rotational motion. As your rod tip moves back, it pulls the line behind it, as seen in this diagram. All of the line moves at the same velocity as the rod tip, which comes from Newton's second law. The system, which is the rod and the line, moves with this new kinetic energy. The air creates some friction here, doing work and taking away a bit of kinetic energy. However, the constant chemical energy being turned into kinetic energy should cancel this out. This gives us our constant velocity. Stopping your hand here actually has a lot of physics behind it. So you aren't actually just stopping your hand, you're quickly accelerating it in the opposite direction of its current velocity until its velocity is 0. This means that your arm turns chemical energy into kinetic energy. But because it never has velocity in any other direction than the direction that the line is currently traveling in, the rod fully stops moving. Once your hand is stopped, it doesn't all stop instantly. Instead, what seems like a wave travels down the line, as seen right here. This occurs because the line is so flexible, so there's little damping. You can imagine if the line was made out of metal wire, it would not all just disperse behind the caster. What you're actually witnessing here is the propagation of force. But what is the propagation of force? Think about a sound. It takes different amounts of time to hit people different distances away from the source. This is because it travels in a wave. It's the same here. So the force of your hand that is stopping the line does not stop it all instantaneously. Instead, there's a temporary disconnect between the motion of your hand and the motion of the line, due to the differences in their inertia, which comes from Newton's first law, and the physics principles of momentum. So the stopping line travels down the line in a uniform wave. The speed of this wave depends on 2 variables in the wave equation for a vibrating string, which are tension and linear density. As illustrated by this diagram, the shape of your loop is very important. You can shape your loop well by having proper timing and proper distances that you move the rod. So back to this equation. For our optimized cast, the tension will be very low because the fly fishing line is firstly not built to stretch a lot, and the net force is pretty small. So we can say it will be 0.1 newtons, and the linear density for this line is 4.39 times 10 to the negative 5 kilograms per meter. Hence, your formula is the square root of 0.1 over 0.00000439, which equals 47.7 meters per second. So the wave for this type of line propagates at 47.7 meters per second. This will change if there's a change in air temperature, if there is a change of wind, or if you change the type of line. Because the line is 12.9 meters long, we can use the formula change in displacement over velocity equals change in time. So 12.9 over 47.7 meters per second equals 0.27 seconds. So you stop at the back for 0.27 seconds. 0.27 seconds was the time measured in the exemplars done by the pros. Therefore, we know our math is correct and we have confirmed the optimal waiting time for these conditions. Back to our cast. So in our optimized cast, we backcast at an average rotational speed of 156 degrees per second. And using the formula for linear velocity and rotational motion, V equals W times R, we can do 156 degrees per second times 2.74 meters from the rod length. Note that you have to convert 156 degrees to radians. So the speed of the rod tip from moment 4 to 5 is 7.45 meters per second. The acceleration is at the start of the cast, and the speed of the acceleration is really fast, as shown in the diagrams at the beginning of the video. Realistically, there is no perfect figure for the velocity of the rod tip. As long as it's quick enough for gravity not to significantly impact the cast, you should be good. 7.45 meters per second is a good speed to aim for because it's easily achievable and works pretty perfectly. With the rod tip moving at the same speed as the line and the line moving at the same speed as the fly, we can find the kinetic energy and gravitational energy of the fly during different parts of the cast. This can be found with the formulas EK equals 1/2 mv squared and EG equals mgy. Considering the motion of the fly, the principles of projectile motion are quite useful here. I mentioned before the disconnect between different parts of the line and the rod tip. The fly is one full line length away from the tip of the rod, and it should mimic its movements plus the other parts. So we can find the timing of this temporary disconnect using the change of distance over velocity. This gives us 1.73 seconds. That means for the parts of the cast that the fly mimics the movements of the rod tip, the fly will make these movements 1.73 seconds after the rod tip does. So starting off with gravity. The arc in the line while it's in the air depends on the rod path. It will travel in a circular position as shown here in this diagram. This allows us to calculate the gravitational energy of the rod. Using Desmos, I came up with an energy time graph. You can see that gravitational energy is modeled by an inverse cosine function with this equation. It peaks at 0.002675 joules and then goes down to 0.001795 joules. For the kinetic energy, the part from moment 1 to 2 is accelerating and therefore has a non-linear parabolic relationship modeled by this equation. After moment 2, when there's constant speed, you can see the kinetic energy does not change and stays at 0.002775 joules. It then quickly slows down, modeled by this equation here. An important factor to note here is the flexibility of the rod. A more flexible rod will build up more elastic energy during the backcast, and when you stop your hand, this elastic energy will be released into the line, speeding it up. The release of this elastic energy turns into kinetic energy, which, as I said, it will speed up the rod tip. However, in this example that we're doing, the rod that we're using is fast action and is not very flexible, so it does not build up a lot of elastic energy. Okay, so some of you are probably watching this now and thinking, stop, you're ruining fishing, just let me fish in peace. What you might not know is that if you ever gone fly fishing, your brain is actually picking up on the timing subconsciously, adapting to mistakes and optimizing your cast. All this video is doing is quantifying these subconscious thoughts into readable numbers. The importance of this is not only to improve you and your fly fishing, but to create opportunity for new things, such as maybe robot fishing or something like that. So why is the timing so important? If the fisher does not let the line fully straighten out behind them before continuing the cast, it causes what's known as the whip. You will know you caused the whip because it makes a pretty audible cracking sound. The whip causes tangles in your line and a pretty bad cast. This is what it sounds like. On to the next part of the cast, the forward cast. The forward cast is extremely similar to the back cast. As you propel the rod forward, the cells in your body turn chemical energy into kinetic energy, twisting your wrist forward. Again, there is little movement in your wrist, but the slight movement has a large impact on the velocity of the rod tip. The only change here is that you are not moving at the full 138 degrees as before. Instead, you stop when it hits 35 degrees because you want the line to fully straighten out in front of you, and then you ease it down so it ends up lying down straight and flat on the water, which gives you the maximum casting distance. Here it moves a total of 96 degrees over 0.86 seconds, with a quick acceleration and slowing down at the start and end. The speed of the rod tip is the same as before, it just doesn't travel as far. It's still going at 7.45 meters per second. Here is the final energy time graph for this complete movement. You have to wait again for it to mostly straighten out at the end of this movement. The reason it is mostly and not fully is because you want to fully straighten out on the water. Because if it straightens out in the air, the phenomenon of elastic recoil or elastic rebound will occur, ruining your cast. Using the speed of the propagation of force, we can find the optimal waiting time and speed for the last part of the cast, which is often referred to as the presentation. This is moments 7 to 8 on our graph. The speed of propagation in this line is 47.7 meters per second, and as found before, the time it takes for the line to fully straighten out is 0.27 seconds. That means we want the total time from the rod reaching the 35 degrees and the cast ending to be exactly 0.27 seconds. In the perfect world, you want the movement of the rod and the presentation to be very slow so you don't send another big wave down the line, which might mess up your cast. There are countless ways to achieve the perfect ending of the cast, and it really just depends on the caster's preference. For myself, I find it easiest not to stop at all, and instead gradually slow down the rod for the last portion of the cast. This is modeled in this graph. Here are my sources I used for this project. You can see the first couple are just the YouTube videos that I analyzed, and then the last couple are some scientific papers written on fly fishing. Thank you very much for watching, and I hope your fly fishing cast improved with this video.